Okay, so we are working on both one step equation word problems, looking for those keywords. And on this same foldable, we are going to introduce inequalities. So take this paper long ways like it is, and you're going to create a shutter. So you're going to fold both of these inward like so. This is going to be the first step. Fold them inward so that you have two windows. And then once you fold them inward, Syrians, you are going to take the paper and you are going to fold it in half. This will create two sections, right? After you fold it in half, you're going to fold it again. How many sections do you think that gives you? Let's see. That gives us 4 sections. And then you're going to open it. So first, we had the paper turn tall, and then we folded it to the middle. After that, we folded it in half, and then we folded it again. Once you've done that, you're going to open the paper, and you're going to cut with your scissors these front flaps from the beginning to the crease. So this one will be cut from here to there to create a window. The second one will be cut from here to there to create a window. Here to there to create a window. And then you're going to do the same thing on the other side. You should have a total of 8 windows. When you have your 8 windows, you're going to return the scissors back to the black table because that's all we need the scissors for. Okay, on the left side, we are going to review word problem phrases. On the right side, we're going to introduce inequalities. Let's go over the word problem phrases first, and we're going to also introduce two-step equations with addition last, okay? Now, I am going to give you some phrases on the outside, and then on the inside, we will put whether it is addition, subtraction, multiplication, and division, along with a word problem and the math to go with it. Now, you can write big on the outside of the little window, but on the inside is where we're going to be writing our work, so it won't be as big. Everybody understand? All right, so I'm going to zoom in for the first window, and there are going to be 2 phrases that we need for the first window. The first phrase is, how much more and already has. And you can, I was going to put that in parentheses. But it's not absolutely necessary. Give me some magic white out right here. There. Okay, the next phrase is in each. And in parentheses, I'm going to put per.
So do you write on when you people do on the other window?
No, you only write what I write for right now. All right, the third one is going to be plus but an initial fee. Do you have enough room above plus? I left off per hour plus an initial fee.
On your initial fee?
No, it has to be before it. And then the last one is lost. Now, what we're going to do on the inside is create word problems. And they have to include these phrases. And an unknown with a total. Okay, so word problem with an unknown and a total. Let's go up and I'll do the first one with you. Now, the word problem for the first one can either be how much more or already has with a total and an unknown. Decide which one you're going to use, and it has to have a total and an unknown. Do you understand? All right, so here's the first one. And I am opening the flap. I'm going to use already has. It has to have an unknown and a total. So my word problem is butterfly needs 32 worms to be happy. Remember, we can scamper our way through this. So there's my total. I'm using already has. Already have 8 worms. Of course, the problem would say create an equation to determine. So I'll say create an equation to determine how many more worms butterfly needs to be happy. Now, remember, you can substitute a different set and change the situation, adapt and make it more complex, modify, and use another situation to create a similar problem. And the phrase can be how much more or already has, but you need a total and unknown in your problem to create your equation. Now, my equation would be my total is 32. Everybody understands that. So I'm going to put equals 32 because that's the total amount. They already have 8 and we're adding to it. So, x plus 8 or 8 plus x would be equal to my 32. And so to solve it, I would need to subtract 8 from both sides to figure out how much they would need to be happy. 24 worms needed. And so in your flap, you are creating a word problem, creating the word problem, writing the equation, and solving it using the phrase either how much more or already has. And you can substitute a different set and change the situation. Now, I'm going to go ahead and write my other equation that will work for this. I can put x plus 8. I can also put 8 plus x equals 32. Both of these will work. Okay, the next one. In each or per. Now, per is in parentheses, so I'm going to use in each to create the word problem for it. I had to think about this because this is not one that just easily comes to mind. Let's see. I'm thinking that I need a total and I need an unknown. Always keep that in mind with one-step equations. You need a total and an unknown. Take it off. So, in each, a, oh, a, a large package contains 343 pieces of bubble gum. There are 7 packages in the package. There are 7 small packets in the large package. Can you see the problem? Can you all visualize my problem?
Yes.
Okay. Create an equation to determine, here comes the word, how many pieces are in each packet. So my equation is going to be, can someone tell me what my equation will be?
Division?
What will it be?
Oh, the answer?
Not the answer, the equation. We have a total. I'll help. Nathan?
Wait, 343 divided by 7?
That's the work to do the problem. What is the equation? You all were very good at coming up with the work that needs to be done. What is the equation? Sasha?
343 divided by
That's the work. Siriansh?
7 times x equals 343.
7 times x equals 343. That is the equation. Now, I can do the work to solve the equation. I'm going to divide both sides by 7. What is x equal to? I know the cube root of 343 is 7. 49. So then 49 pieces per packet. Okay. Now, your turn. You can substitute, change the situation, and modify it. To create an equation, to create a word problem, and write the equation and solve it. I'm going to give you 3 minutes for this one because It's a little challenging. Remember, the word that you are looking for and that you have is each. In each. In each, you need a total and an unknown. 3 minutes. All right, the next one, we're going to go to the bottom one, and the word that we're using is lost. Keep in mind, we need I'm going to write this down for those who don't know the parts that we need. A total, an unknown, and the keyword. The total is what it is equal to. The unknown is the variable. Okay, so the word is lost. Robin had 80 coupons when they arrived. They noticed some were missing. When they counted the stack, there were only 53 coupons. Create an equation to determine how many were lost. Well, there was a total of 80. And so X minus 53 is equal to 80. Or I should say X plus the 53 is equal to 80 because that is the total amount that they had. And so to figure out how many were lost, we should subtract. You have 2 minutes.